So random tensors. Why do we require random tensors? That's the question. A random tensor consists of a random numbers, right? So why do we require random tensors? See, when we saw neural network theory, in that we discussed that we initialize the weights, right? We need to, when we train the neural network, we need to initialize the weights, right? So this weights initialization is usually to random numbers, right? So these weights are initialized to random numbers, right? And these weights are nothing but tensors, right? We input the weights are in the, we represent weights in the form of a tensor matrix, right? So these weights are tensors and they are usually initialized to random numbers. So that's why we need to see, or we need to study why, how can we create random tensors. So let's see how to create random tensors. So here if I let's say the name of the tensor is RT1. RT1 stands for random tensor 1. So there is a method, or there is a class in TensorFlow tf dot random dot generator. On that class, I'll call a method called as from SID, and we are going to set the SID to 52. The reason to set the SID to some number is whenever we reproduce these random numbers, we'll get the same random numbers, right? Or when I that means these are kind of pseudo random numbers. So let's see how. So if I now RT1 is equal to, if I create the random, first I set the seed and then we create the random numbers by using normal distribution. Let's say RT1 dot normal, and to this I'll pass the shape. What is the shape of the tensor I want to create? Let's say shape is equal to 4 3 comma 4, let's say, and let's print that random tensor 1. You see we got this tensor. Now the shape of the tensor is 3 comma 4, means here there are, this is a 2D tensor. 3 comma 4 means there are 3 elements in a 2D tensor and each element has 4 sub elements. So there are 3 elements in 2D tensor. First element is this 1D tensor, second element is 1D tensor, third element is 1D tensor, and this 1D tensor has 4 elements: 1, 2, 3 and 4, right? So that's the meaning of shape. So now let's create one more tensor, one more random tensor, and see, and same shape since tensor will create. Let's see what happens, right? So RT2 is equal to tf dot generator. Again we'll set the shape to, or SID to 52, let's say, from SID, that is 52. Now we will have RT2 is equal to RT2 dot normal, and to this normal will pass shape is equal to same shape 3 comma 4. And if I print this now, if I simply say RT2, right, and also if I print, let's first print RT2. So yeah, if you see this now, you got exactly same tensor, right? So this you have here, if you see here, you have here this number, same number you got it here, this number, same random number you got it here, same number here also, right? So this one, right? So exactly same tensor you got, right? That is because of this SID 52. Because of this, SID is set to 52 here, SID is set to 52. Now when we set a SID and reproduce that tensor, you get the same random numbers, right? So now if what will happen if I change the SID? Let's change this SID, or first let's check how are they equal, right? So if I print tf RT1 equal to RT2, Let's check that, right? What will happen, right? You see true, 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 right? So that means RT1, this every element of RT1 is equal to every element of RT2. That's why we got all truths, right? Now if I change this seed to, let's say, 32, right? 32. Let's see what RT2 we get. So we got the RT2, this one. Now let's check whether RT1 and RT2 are equal or not. They're false, right? They're not equal. RT1 and RT2 are not equal. That's the use of setting the seed. If you set a seed to some number and reproduce the random numbers, you will get the same set of random numbers. Though they are random, though they are randomly generated, but they are same if you reproduce them, right? So that's the use of seed. So that is how we can create or generate a random number tensor.